Welcome to today's Software AG webcast titled AVX SAG System Replatform IBM Mainframe to Linux. Today's webcast will be presented by Randy Martin, Systems and Programming Manager at AVX. As we move through today's presentation, I invite you to submit any questions that you may have via the Q&A box, which is located in the lower right corner of your WebEx session. We will do our best to answer all of your questions. In the event that we're not able to answer your question, your submission will be recorded, and today's presenter will be back in touch with you as soon as possible. Additionally, today's presentation is being recorded. This recording will be available to you via YouTube should you wish to access it later on. To receive a copy of the YouTube link, please send an email to the webcast host. Before I turn today's presentation over to Randy, I would like to briefly introduce you to Software AG. Software AG offers the first end-to-end digital business platform based on open standards with integration, process management, adaptive application development, real-time analytics, and IT portfolio management as core building blocks to help customers build their digital futures today. With over 45 years of customer-centric innovation, Software AG is ranked as a leader in many innovative and digital technology categories. Software AG has more than 4,300 employees and is active in 70 countries. It is now my pleasure to welcome Randy Martin.
Hello, my name is Randy and welcome to the presentation. A little bit about AVX. We make passive electronic components and connectors. What that really means, we make parts that go inside of parts. So if you're sitting on your computer watching this, we're probably in the computer, the tablet, the iPhone, the car that you drove to work in, the plane if you flew there, the satellite that gave you the GPS. So AVX is in just about anything that's got electronics, but nobody knows us because nobody buys AVX. You buy the parts that we go into. As a worldwide company, we about 1.3 billion a year in sales with about 10,000 employees. We are a US-based company, but we're about equally distributed between the US, Europe, and Asia. We have sales manufacturing facilities in each of those locations. We have 3 data centers. Our primary data center for the Americas is in Greenville, South Carolina. And we also have data centers in Europe and 2 big ones in Europe. So that's what AVX is. So what was, there is SAG. So we got started in about 1986, and we went with Adabas Natural, and we started writing our order entry system. So for 22 years, we have been building natural applications, and these are the critical applications that are running our business. It's our sales entry, our sales and order processing system, so this is what takes the orders from the customers. It's what tracks and helps make our product through the manufacturing process, and this is what ships it out the door. So this is our company. If any of these systems have problems, this is affecting the CEO, and we will hear about it. So now we also have non-SAG products. Everybody's got your regular financials. But again, this is what's running our company, and we are spread all over the world. So our systems are primarily supporting the Americas. Europe systems are supported primarily by Europe, and we do have Asia. So we are 24/7, 365, and given that we're in Asia, we have problems with nighttime support and everything. So anyway, we're plugging away building systems for years and years and years, and then in 2008, we dropped SAG support. Well, first thing you probably think of when you drop SAG support is you can't call SAG if you have any problems. That's true, so you better not have problems. But the other drawback is you also get no system upgrades. You get no patches, no zaps, no PTFs. So really you have to stop all of your system changes as well. So we were running on an IBM mainframe, running MVS 210, good old-fashioned 3490 tapes, running our basic Adabas Natural types of applications. We do report bursting. What report bursting is, we are an international company. We have to take reports and send them all over the world to different people, but we don't want to send everybody the entire report. So the system will produce one report, and then we will burst it or break it up into all kinds of little pieces and send them off as appropriate. We have a batch scheduler because we're running hundreds or thousands of batch jobs. And as well, again, we have other applications such as accounts receivable, accounts payable that are running on the mainframe. But at this point in time, we can no longer change the mainframe. We can't do any operating system upgrades because one of those could require an database fix, and we don't have access to those. So starting in 2008, we freeze everything except the applications. We need to keep developing those to support the business. But the operating system and all of the SAG products are pretty much set in stone. So starting in 2008, we just decide we're just going to keep on running. So we know we've had to freeze the operating system, so we start working on plans to move all of the non-software AG applications off the box, and that's the purchase system, so we start moving those. But our software AG system is running, and it's a very stable and solid environment. We have upgraded our mainframe during this time. You can't buy a mainframe that runs MVS anymore, not MVS 210. They're just too old. But luckily, IBM has VM, and for all you VMware and Citrix people, yes, IBM had VM operating systems and virtual machines long before VMware even existed as a company. So we're running a nice new hardware, all supported. We've got fast redundant SANs, and the systems are just stable. We've been running for years and years. We know how to keep it going. And for everybody that, again, does software AG products, Adabas Natural, they are very stable. And we've got pretty much the same staff that we've had for years and years. So we are able to keep the system up, running, stable, and all is pretty good. Except by about 2013, we start really going, we really need to look at the software AG system because we've got to do something. First of all, it's just expensive. Running on an IBM mainframe is a very expensive thing to do. And we're thinking, well, with all of the technology out now, there's got to be something that's less expensive to run it on. As well, we're getting kind of cannonballs getting shot at our nice little stable world. First of all, we're stuck at 2008. Well, a lot of software packages and upgrades and improvements have been made to the products, and we can't take advantage of anything. We're still running 2008 technology. So we're missing out a lot of opportunities. As software AG will talk about, a lot of their problems are that many of the software AG people, not software AG, the users are older. Our operating system person is retired. And again, we're not making any changes, so that's okay. Our DBA is planning on retiring soon. So that's going to be an issue. We're going to have to train somebody up. Some of our software is getting very old. The ACI servers run on XP. That's not a really supported product anymore. You can protect it through the network if you have to, but we're still stuck running on XP boxes because we're not licensed for anything newer. And there's also this kind of fear that it's been 5 years and we're up and running and stable, but we still have no support. If we have a big disaster problem, we can't phone anyone for help. And that's just kind of a scary way, given that this is what's running our company. And we're also a fear that one day somebody's going to give us a requirement we just can't meet. And mostly concerned, I guess, with the government. They're going to put out some rule, regulation. We sell parts to the U.S. government. And they're going to say, you have to do something, and we won't be able to do it. At which point, it'd be kind of hard to meet that requirement because you'd have to upgrade or convert, and where would we even get started? And another little problem, which is only a problem if you have a disaster, is that you don't have a spare IBM mainframe sitting around. They're pretty big, pretty expensive, so you go to a DR site that hosts IBM mainframe for you. Well, the site we chose was 10 hours away. And one of the fears we've got is if we really did have a disaster, how would we get to it? It's 10 hours away. Who knows the conditions of the roads, the airlines? So how would we get to our DR site to recover our systems? And the other problem is, who would go there? it's a natural disaster, people are going to be dealing with their houses, their families. They may not be able to get there, so how would we get our tapes up there to restore? How would we get our people up there to restore? So that's a big concern because, again, this is running our system. We stop taking orders, that's going to have a material impact on our company very quickly. So by time 2013 comes along, we decide we're going to start looking at options. And the first option we looked at was go out and buy one of these big ERP packages, SAP, Oracle, JD Edwards. And we did quite a bit of looking into these products, and we use these for some of our other systems. But the first things that come up are millions and years, because that's what it takes to implement either of these guys. Years and years of work, consultants, contractors. That's a huge investment, and when you're done, you have a completely new system, so that's a big risk to the business because now you're running your entire business on new systems versus systems that have been tweaked and fine-tuned to do exactly what we want. So we looked at that and just said that's just too much of a risk for our company. So our next choice was, well, we've got AVX has got systems in Europe that run the business there. Why don't we just convert to their systems and only have one system? Well, yes, they're AVX, and yes, they are in similar business that we do, but they have different business practices. We're in the Americas. There's certain rules on how we sell, how we've written contracts with our customers and our vendors, and those just aren't supported by the European system. So we would have to make a lot of changes to their system to support us. Well, that, just as our system, is a homegrown system. So you can't contract out people. You can't hire people to help. You have to do it with the people that are in-house. And that, looking at that project, that's back to the, it's going to take years to do this. So it wouldn't cost as much to implement, but we're back to years of implementation. And we're just looking for some way to get off or to get back to something a little more reliable, a little faster. The third choice we looked at, and this was a pretty neat idea, there are companies that will come in and they basically have, whether you want a C#, a .NET, Java, basically they run an interpreter where they create language statements and they convert your natural to their language conversion. So they basically take each line of natural and they recode that into a language that you choose. They don't really look at the program and redesign the program to that language. They really just take the natural statements and convert the statements into their product. With it, you can pick whatever database you want. You don't have to stay with database. You can, whatever systems you want. And we looked at these things, but there were a couple of big problems. First of all, they basically took the natural and converted it into this language, and you ended up with a .NET program written for natural, and it just didn't work the way .NET worked. And we talked to companies, and they said, well, if all you're going to do is make a little change to a program, no problem. But if you're going to make anything major, you pretty much ended up rewriting all the programs as you touched them. You had this mid-tier framework, and that's, again, the interpreter that says, here's the .NET command equivalent of the natural. And that's something that whatever vendor you buy, you have to keep maintaining going forward. And the big problem was performance. For example, one company we talked to had spent 2 years trying to get their system converted to run on Oracle, and they just couldn't get it to work because you're taking a language written for an operating system in a database and trying to kind of shoehorn it into another type database, and it just doesn't work. So we really just decided that this was too risky. We'd end up running all of the systems that run our company on this new technology. It's very hard to change, hard to work. The day you go live, there were a lot of fears. So it was just simply, we just couldn't afford the risk. So at the end of 2015, we said, well, maybe the answer isn't to get rid of Software AG. Maybe the answer is to get back with Software AG. And the two biggest criteria, the two biggest concerns we had was it was least risk. We weren't converting to an entirely different platform as in language operating system. It was still going to be Adabas Natural. And where the other projects all were defined in years, these Software AG said we can do this in months. So safer and faster. That was the two biggest reasons why we decided to go with it. A couple other things, all the other systems that we communicated with through EntireX didn't need to change because EntireX would still come along with the upgrade. And if we did go to something like .NET, Java, our people didn't know how to do that. Well, we all had many years experience with Natural, so by staying with Natural, we had a fully trained staff ready to go. They also had a Linux solution, and that was one of the big problems we got was simply the cost of the IBM mainframe and keeping it running. So this got us away from those costs. So in the end, getting Software AG back really didn't turn out to be any more expensive than the other options, and it was faster and easier and safer. And the other little side effect was there was no training costs for this. Because once you're into Natural, whether the Natural ran on the mainframe or the Natural ran on Linux, it really didn't look any different. So once you got into the application, the look, the feel, how it worked was no different, so we didn't need to train all our people. And we'd get a few nice things along with it. We'd get Adabas Natural, but we would also pick up Adabas SQL Gateway. That was part of it. And what SQL Gateway does is it says from our PC-based applications, we can now access our Adabas database through just regular SQL. And that was one of the issues that we had to build interfaces through EntireX or other ways to try to get from our PC-based systems to Adabas. So along with this, we'd get Adabas SQL Gateway, and that would solve the problem. We'd also get Entire Access, and Entire Access goes the other direction. That says from Adabas Natural, I can now read my Oracle databases and my SQL Server databases. So now instead of having to use EntireX as a middleware for simple data access, we can now, from our mainframe, go to the PC, and from the PC, go to the mainframe and access the data directly. So 2016, we signed the contract with Software AG to do our replatform. And what Software AG brings to the product or to the project is they're going to be the project management. This was really critical that Software AG did this. We didn't have the people to become a full-time project manager. We are down to enough people just to run the systems we've got and to support them. We don't have somebody that can spend full-time running this, and also it's a skill that not everybody has. So Software AG gave us a project manager, full-time, dedicated, working just on our project. So the other thing that Software AG did is they came on site to actually help with the installation and the configure of the products. We wanted to support our own systems. We did not want something where they would just deliver us some boxes and say, there you go, from now on, good luck with them. So they actually came on site, sat with us, went through the installation, and worked with us and trained us. That was a big deal even more because our DBA that was going to retire had said she would stick around to work with the mainframe, but she wasn't going to do anything in the Linux world. So we had to train a brand new DBA who knew absolutely nothing. By the way, that was me. I'm now the Adabas DBA as well. One other thing they'd do is they would have go live support. So physically, when we were ready to implement, they were going to bring a person on site, or did bring a person on site, and they sat here. We had problems when we go live. We didn't want to have to phone support and wait for an answer. We wanted somebody right here that we could yell and scream at and stamp our fists and say, help us get this fixed. So they actually had somebody sitting here with us when we go live. Software AG also did, physically, they did the natural security and the Adabas security. We use Ada SCR, security by value. Software AG converted the natural security and Adabas security for us. And they brought all their products along with us, the Adabas, the natural, and all those pieces. Software AG had a business partner called Kronos, and they're out of South Africa. And Kronos is the one that you would think of that actually did most of the work. Kronos converted the actual natural programs for us from the mainframe and, again, from 2008 version of natural. Surprising, they actually converted the Adabase. I would have thought this was something Software AG would have done, but Kronos actually converted our Adabase databases from the mainframe to Linux. Kronos also did all the JCL and RJE conversion. There's no such thing as JCL on a Unix environment. You have to convert that to another way to run batch jobs. And the flat files. Unfortunately, there's integers, pacts, binaries in flat files. Well, you can't FTP one of those files from a mainframe to a Linux environment with an integer pact binary or a negative number in it because they won't translate correctly. The FTP thinks they're all characters. It doesn't know that those are really integers, and it won't convert them. So you have to run all the files that have to get copied down. You have to run them through a converter to convert them to ASCII. Kronos provided 3 of their products with this. First was ESP Batch, and that's really what you kind of think of when you think of the MVS JES operating system. Linux runs the physical machine, but ESP Batch is the tool where you go in and you actually edit the SCL. That's where you run the batch jobs, you look at the output from the jobs. All the things that you do in TSO and JES, that's what ESP Batch does. Included with it, they also had a bursting capability, and that was something they actually had to enhance for us. They had bursting, but it didn't do quite what our product needed, so they actually made modifications to their product to support what we needed. Second product, ESP Auto, that was your batch scheduler. We decided I'll get to that. So that was what actually runs the batch jobs at night. And then they have a control system for the source control, and the source controls both the natural programs, and they call it SCL, script control language, instead of JCL, so it manages the programs and the jobs. They also gave us a Unix menu system so that when the user logs onto the Unix system, on the mainframe they logged in and they got to CICS, and that helped them navigate into the natural programs. So they had a menu system that would do the equivalent of that. Well, if that's all the stuff that Kronos did, you're thinking, well, what did AVX actually have to do with this installation? Well, we had to install all the hardware and software, and we actually started this before the project even started with purchasing the software, and then we started actually installing it all. So, for example, with our QA system, which is what we built first, Software AG pretty much sat with us, and they went through and they did the install of me sitting beside them and answering questions. How do we want to do things? How do we configure? But it's pretty much Software AG driving, and we're just talking and I'm learning how it works. When we install the second system, which was our test system, now we kind of flip the tables. Now I'm sitting down at the keyboard, I'm doing the installation, and SAG is sitting beside me and helping me fix the documentation and answer the kind of questions that didn't come up the first time with the QA. And by the time we install the prod, pretty much that's AVX doing the installation. We still have SAG here, they're available to answer questions, but we try to pretty much do it all ourselves because we're going to have to support this system when we're done. We want to be able to support it. We don't want to have to call SAG or contract services or anything every time we want to change something. So we're kind of adamant that we installed the software and understood how it works. There's also the Kronos software that had to be installed, and we did some of that, but Kronos helped with that. And there was a bunch of third-party software. And this, again, something that Kronos kind of gave us a help with figuring out what we needed. And that you need a print spooler, and there's some better security features than what Red Hat Linux, we used Red Hat Linux, than what Linux actually provides. So we installed it, and again, we wanted them to teach us how to install it, how to make it work. We didn't want some turnkey system that we couldn't support. Even before we went with SAG, we knew we were going to sign the contract. We had to get a head start with some of our system conversions that weren't SAG related. We still have COBOL, and we had a product called EasyTree, which is pretty much a report writer, those programs had to be rewritten in Natural so that they could go with the conversion. You're not going to get COBOL on Linux. And we had some VSAM. Those files had to be converted to database. So we did some preliminary work to get ready so that we could actually do the database natural conversion. We also had to deal with a bunch of systems, one of other systems that weren't Software AG, including web methods. We actually had web methods before it was Software AG. And we send data from the Database Natural applications to web methods, and web methods sends data back, and web methods actually ran JCL. It would FTP the JCL to the mainframe and run batch jobs on the mainframe. Application testing. Anybody can test that the program compiles, which is basically what Cronus can do. They can look at the natural code, they can convert it, they can see that it compiles and it runs, but they can't look at the data to see if it's right. They don't know if you put an X in here, you should get a pop-up message. They can't look at the numbers and say, no, those numbers are too low. So we actually have to, AVX is the only ones that can really test the application. And that was MIS users could test it, and we also had to have some business users to test it. They're the ones that use the applications. So we had to test it. There were a lot of programming changes that were made for the language changes, the environment changes, and it was just a lot of testing. Our batch scheduler was on the mainframe, and we didn't even try to convert the scheduler to the Linux world. The schedulers worked with different concepts of how they scheduled jobs. But the biggest problem was our schedule on the mainframe had 30 years of people tweaking it. There were jobs dependent on each other for no other reason than if you ran them both at once, they slowed the system down or made it unresponsive. People would have dependencies in there because 20 years ago we did something and then we changed it, and nobody fixed the scheduler. So basically the schedule was just 30 years of this big mess that nobody really understood. So we took this as a chance to say, we're just going to start from scratch again and build the schedule the right way the first time so that it makes sense and really simplified the schedule. We had to identify all the work files that had to convert. Big part of this was if the first time you were going to read or write a work file, you were going to write it on the Linux. So you're going to read an database program, write out a work file. You didn't need to convert it from the mainframe. So that was easy. But if the first thing you were going to do was read yesterday's file, the month-to-date file, the year-to-date file, and you had to read it on Linux when it had been created on the mainframe, we had to actually convert all of those files because, again, you can't send a work file with an integer or packed or a binary field in it with FTP. You actually have to run it through a conversion utility to get it down correct. We would install the emulators. We used to use a TN3270 emulator for MVS. Now we had to go to a VT220 emulator. And part of the trouble was that we weren't just AVX people. We've got all our AVX employees that have to be changed, but we have an external sales staff. And these are primarily two types of people. We have reps, or representatives, which sell our product for us, and they work exclusively for AVX. And these tend to be smaller offices, and they're kind of done by regions of the country or countries. And they access our system. And we have something called a distributor. And that's what you think of if you were going to buy an oil filter for your car. You don't phone up the factory that makes oil filters. You walk down to your nearest Advanced Auto Parts or AutoZone, and that's a distributor. So the distributors access our systems as well. These are the big companies that they sell electronic components. They buy from any maker, any manufacturer, and they sell to whoever wants them. Well, they've all got access to our systems as well. So we need to fix the emulator on AVX people and these other two types of people. And one of the biggest problems we've got is we have a pretty small staff, and we were full-time keeping our systems running. Now we have to spend time converting systems and testing and all this work. Well, our users don't care. Our users still have their business problems, their customers calling, things are still needing to change. So you really need somebody in your company that can go to the users and say, I'm sorry, I know this is a problem, but it's just going to have to wait. We need to spend time working on this conversion, and in turn to be able to say, sorry, this really is a critical problem, and sorry, you're going to have to stop working on the conversion. You got to go work on this. And that's really important. If you leave that up to each of the people, each of the programmers directly, you're never going to get things done. Nobody wants to say no to a user. So you need somebody that's kind of far enough up the food chain that can say yes or no and make sure that the people are working on what needs to be worked on. So actually, who are these AVX people? We're a pretty small team. We have one new DBA and one Linux person. Our application staff consists of 8 programmers and 1 manager. So that's the entire team that is going to do this conversion with the help of Software AG and Kronos. So to get the project started, we take all of our JCL and all of our natural and Adabase and we send it to Kronos or to Software AG, and they start working on the changes. Just to give you an idea of size, there's about 850 JCL, 80 RJEs, and these are a combination of web methods, scripts, FTPing JCL to run Adabase, and the rest of them, and most of them, are simply online natural programs that submit JCL through RJE. Some people call it hot batch, but they just run programs from the online. Natural-wise, there's about 9,000, little over 9,000 natural objects between programs, data areas, maps, all those things. There's 9,000 of those. And we have 17 years of Adabase backups. Now we have to convert all 17 years of the backups because we're not going to have an IBM mainframe running Adabase to be able to restore if we need to go back. And on the mainframe, we actually ran physically 2 Adabase databases, and that was a function of the operating system and the DBAs, just how they wanted to run it on the mainframe. Physically, we had 2 databases. We didn't want 2 databases going forward. We merged that into one big database, so you had the problem with files from multiple sources. But that was all done. So we buy the hardware, we start configuring it, we do some training because we know nothing about the Linux world and new DBA. So we send the code off, they start the conversion. When they're ready to, just before they're ready to deliver the code, Kronos comes on site and they help us to use the ESP batch, ESP auto software that we're going to use going forward. So this was the schedule, and this was kind of funny. Software AG sent us the schedule, and they said it's going to take about 18 to 20 weeks, and it's going to take about 6 weeks to convert the natural. And we all looked at this quote, and we're kind of chuckling to each other, and we're going, they didn't even proofread this quote. It said 6 to 8 weeks, or 6 weeks to convert the natural and 18 weeks for the project. We're like, it's supposed to be months. They didn't even proof it. They didn't even check that they had the right date on these things. So we're sitting around kind of chuckling that they sent this to us. We got on the phone with them, and the first thing we said, hey, there's a typo in your presentation. It says 8 weeks, not 18 months. And they go, no, 18 weeks is right. We all kind of sit there with this kind of shocked look on our face going, but every other system we looked at or solution we looked at was years to convert. You guys are telling us 18 to 20 weeks? What? Well, are you sure this is the right project? They assured us, yes, that really was the right project, and it really was 18 to 20 weeks to get this project done. And we just kind of perked right up and said, ooh, we're liking this idea. So this was the actual initial schedule. And basically, we would send them the natural code and all the JCL, and they would convert it. Once it was converted, they would give it back to us, and we would put it on our systems and start testing all the code out. While they were off converting it, we bought the hardware, got it in, started working with SAG to get the installation of the software all done. And so that was the project. We were going to start in early April, and at the end of August, we were going to go live. So what was the new world going to actually look like? Well, in our Greenville data center, we would have a Linux server to run Red Hat. Again, we chose Red Hat Enterprise Linux. That was Software AG's recommendation. And we would have nice high-speed network with a small group of SANs to store all the data. We would still have a tape backup system. Still needed to do that weekly, but one thing we did do is we said no tapes during the batch processing. We were on an IBM Mainframe. You had a job that needed a tape. You had to alert the operator. They go over, put it in, it reads the tape. Well, that all takes time. And 3490 tapes are really slow. So that was a big performance issue. So when we did this, we said no more tapes in the batch process. We'll still use tapes to do backups just for disaster and for protection, but they're not going to be part of the production cycle. One of the other things is we've had problems in the past with SANs going down, breaking, storage issues. So we decided we wanted two completely redundant sets of SANs in two physically separate locations. So in a different building in our facility, we have a duplicate set of SANs, and those are replicated real time. So they're mirrored copies of each other, up-to-date, guaranteed, reliable, mirrored. And the idea was that if in our data center the sprinklers let loose and flood or spray water all over the SANs, or a motherboard blows or something, that we would still be able to function with a completely separate set of SANs. And if something happened drastic, a plane hit the building or the roof collapsed or something, that we would still have all of our data accessible to us in a separate location. The other thing is DR. Well, these are just commodity boxes now, just Linux servers. They're not like an IBM mainframe. You can actually afford to buy these and keep them. So now we have a very close DR site. It's 20 miles away, 15, 20 miles away, and we can physically host our own separate equipment for our DR site now. So instead of this problem we had before with how are we going to get to DR if there's really a disaster, now that problem's solved because we can get to it. It's only a few miles away. And it's also network attached to us. So one of the things we can do is instead of having to worry about hauling all these tapes up there, we can now transfer files real time during the day. So when we do a backup in the morning or at night, we can actually send that backup across the WAN to our DR site and hold the data there. Now we are a cold DR site. We don't have Adabas up and running, but we can have the server up and we can transfer backups and copies of flat files. We just can't run Adabas. So that's the way our new system was going to look. And we always had the concern that we were an big IBM mainframe, big iron, that we were going to run on a little Linux server. So we're always kind of nervous, and Software AG always just says, trust us. We know what we're doing. We've done this before. You'll be happy. And in fact, batch in the Linux world is screaming fast. You're going to love this. It's going to be so fast. They're like, no, just trust us because we know. Well, there's the comparison. That box I'm holding, and that, by the way, that's me. That box I'm holding is the new Linux server. That big Z114 mainframe behind you is what we used to run on. And that's a big change. Now, a couple of side effects that we didn't plan on, or at least weren't part of the justification for this process. Size of our data center. We got rid of that box, that mainframe. Now we don't have to worry about the space requirements, the power requirements, the cooling requirements. Now we're just on a 1U rack server. So that was kind of nervous. We're going to go from that size box to this little box. Ain't technology grand. That tape, that's one of our operators. That tape he's holding is the tape for our new tape backup system. The entire 2 racks behind him and all those 3490 tapes, they don't add up to as much storage as that one tape he's holding in his hand. So this is, again, all kinds of storage space that we've recovered within our data center. Wasn't part of the justification, but it was a very nice side effect. So we send the code off to Kronos. They've got to convert it. Now, some things are just you look at Natural 314, which is where we were, to Natural 837, there's just some simple code changes that just have happened in Natural over the years. And Kronos had these defined set of rules, and they said if it has this code, I'm going to convert it to this new code. And I don't know if I don't even think they really did this manually, or they had some automated tools, but when it converted the code, it also commented out the old code, installed the new code, and put in a comment that said exactly why this code was changed. And that was nice. We're publicly traded U.S. company, so we have the dreaded SOX auditors. So the auditors were pretty happy because it had the old code, the new code, and why it was changed. And in the end, about 1,000 natural objects ended up being changed. About 5,000 lines of code were changed. And many or most of these code changes were well documented because it said this rule, this reason, here's exactly why it was changed. So that made it much easier to get this past our auditors that were concerned about thousands of objects being changed and wanting control over that. The other change was EBCDIC to ASCII. When we're on the mainframe, when you read, it goes ABC, A to Z, and then 1 to 9. So if you're going to start reading with everybody starting with ABC, you'd say ABC through ABC 999. Well, that doesn't work in Linux world because it uses ASCII, and in ASCII, the numbers are before the letters. So everywhere that you say read from some value through some value potentially has to change. Now, if you were nice and you said put hex Fs as your ending value, then it worked. But if you put 999 as your ending values, all of those codes had to change. There's no such thing as JCL on the mainframe. Kronos has something they called SCL, Script Control Language, and that's not a script like a Unix script that you would think of where you read a shell script. It's actually stored in an database file. So they've got to take all of our JCL and convert it, but the biggie, the JCL we'll get to in a second, the biggie is the RJE because that JCL is buried deep inside of natural programs. So it's a lot of changes because it's not a one-to-one line change. You can't just say, I'm going to run this little script. It's a lot of JCL changes or natural changes to change it from JCL. That's the RJE. They also have to change the JCL, and that's just your plain JCL sitting out there. They converted all of those. One thing Linux doesn't have is GDGs. The ESP batch product supports GDGs just like we're used to, so we don't have to change all of our jobs. And some of these things kind of came along with nice side effects. One of the nice side effects was that GDGs in the Linux world, the way Kronos implemented it, in MVS, if you have a data set and you create a +1 data set in the first step in the job, you reference that as +1 all the way through the rest of the steps in the job. The problem is if the job abends in step 2, you've got to, when you go to resubmit the JCL, you've got to go through and change all the GDG references because it's no longer +1, it's now 0 because it's now a separate job. So you have to remember to do that. Well, it's not bad if you forget. You submit the job, the JCL happily blows up because it tries to reference a +1, doesn't exist, and you fix it. The really scary part is when you referenced a older version. So if in your JCL you referenced the 0 version, because now when you submit that JCL, if you weren't careful and looked through, it doesn't have a JCL error. It would run it because it finds the 0 and get an error. Well, with Kronos, when the first step creates the +1, when that step's finished, the next step now references it as 0 because it's now the current version. And that means if your job blows up and you have to restart the job, you don't have to go through and fix all your GDG versions. So that's one of these little perks that just kind of shows up that you're not expecting. Everything in JCL is not just running natural programs. You call sort programs, and the sort program on Linux and Adabas or on MVS were different, so all of our sort commands are slightly different. Now, luckily, the company that provided the sort utility had an online web interface where you could take your sort utility from MVS, you could take your sort commands, copy and paste it into their web utility, and it would show you the equivalent commands for their utility, for their Linux version. So that helped. That saved a lot of work with sort statements. And even then, not everything is sort natural. You call all kinds of system utilities, IBGener, IFBR14, all of these utilities that are part of the MVS operating system, they don't exist anymore. Now you have to call Unix equivalents of them. FTP statements changed a little, but not much. We use something called remote exec, which allows one system to submit a task on another system, like remote shell that is on Linux. And we use that a lot because we had our mainframe scheduler, and we had all kinds of Windows servers that need to run jobs, and we need to control them in sequence. Well, we used remote exec from the MVS system to run all of these scripts on all of our various servers so that we had one centralized job scheduler. Well, we want to retain that function. We only want one scheduler. We don't want to have to try to coordinate batch schedulers on different systems. And, of course, database utilities. Now, the nasty part of this, and we'll get into this a lot more, was on the Linux world there are two types of work files. You can define a work file as type ASCII, and ASCII is just your plain text file. It uses carriage return line feed to mark the end of the line of the file. The other type is type SAG. And SAG is, instead of using a carriage return line feed to mark the end of the line, it has the first couple of bytes of the record are the record length. So when you read a SAG file, it reads that first couple of bytes to say, hey, each of these records is 80 bytes long, and then it just simply reads the 80 bytes. The reason it's critical is that, again, if you have integers, pacts, or binaries inside of a work file, they're encoded just as their binary values, basically. Well, that can have the same value as a carriage return or a line feed in ASCII. So if you're going to have integers, pacts, binaries, you need to use type SAG. So you have to look at each work file you use and decide if it's a SAG or an ASCII. And then one of the other changes was, again, no tapes in batch. We were going to do everything to disk. Disks are big and cheaper now, so we're just going to store it there and get rid of storing files on tapes. So we just start off, they've converted it all, they give it to us, and we're going to start testing the software out. Well, we kind of had three types of issues. First one was system issues. These were nothing to do with really the applications themselves. It's the fact that we're running on Linux using different tools, different versions than the mainframe. And we had some Linux experience, but not a whole lot. So we're learning. We have emulator issues. VT220 emulators work very different than TN3270s. The keyboards are different. The colors are different. Third-party software is different, so we have to learn how this print spooler works and how the sort program works and all kinds of security issues. Again, we're Sarbanes-Oxley controlled, so the auditors are all over security. And web methods, we actually have to integrate with web methods, and web methods can no longer submit batch jobs or can run batch jobs by just FTPing the JCL to the mainframe. So that was outside of the scope of the Software AG products. Even though web methods is theirs, it's not used that way. And then obviously we have issues with the applications. The work file mismatches. If you defined it as SAG and it was hard, the trouble with SAG is you can't just edit SAG with a plain editor like Notepad, TextPad, Notepad++. You have to have special software to read a SAG file. So we preferred to make them ASCII. But if you defined the file wrong, you just had to change the SCL and say, all right, it's type SAG versus type ASCII. There's no natural coding changes. Natural doesn't care. It reads it on the fly. But you need to change the SCL to say it's ASCII or SAG. Well, that's not bad if you just had to go to one place. But if you change a file, you change the SCL where the file's created, but then you got to go change the other 15 jobs that use that file, because every one of them has the file defined that way. So one file change and you're off changing 15 or 20 JCL entries to make it work. So that's a lot of work. The environment, again, it's just different. So sometimes programs just function different or work different in the two worlds. We had the AVX to ASCII problem. We talked about that before. Everybody probably has this problem. You've got all these little reference tables. So you build this file, we call it our tables UV01. You build a little file where you've got a 10 or a small key field, and then you've got a big character field. And what you do is you store your keys, and then that character field, you redefine it out. So if I really want a field with a table with 3 fields, I redefine this big alphanumeric field into these 3 fields with a redefine. Well, if those fields you redefine out as integer, packed, or binary, again, when they converted the Adabase, those fields don't convert because it doesn't know they're really integers. It thinks they're characters and messes it up. So if you have these embedded numerics inside of alpha fields, you have to programmatically go fix those Adabase records. Then there were a few differences. Just we went from version 3 to version 8, and some things just worked a little different. Things that were basically, I don't want to say you could get away with more things in version 3. You could do things with the language that probably weren't expected to be done or shouldn't have been done. By the time version 8 came around, they tightened up a lot of those things. So we ran into some of those problems. As far as the RJEs, that was tough to convert because you really had to understand the programs and what the JCL did. So it was much harder to convert the RJEs than the JCL. And we really almost had to go through every single RJE job and test it and make changes to it. So it was a lot of work testing the RJEs. And something you don't think about, but we've got all kinds of users testing, and somebody's trying to test a batch job and an online, and you just mess up each other's data. Somebody runs the monthly job and tests it online, and it's different. So we ran into problems with having people testing over and over. That wasn't a big deal, but it did come up. And a few things were kind of new. For example, on the mainframe, there's no such thing as an SH command, SHCMD command. Well, the default out-of-the-box setting from Software AG didn't work. We had to change that. Again, that was just something new. Not too many of those kind of issues. The biggest issues were just the emulator issues, trying to things work different between the BT220 versus the TN3270. And we also had to test, which was kind of outside of this project, but we had to test how it integrated with all the other AVX systems. That's not something SAG or Kronos could help with. That was our system to our system integration tests. So what went well and what didn't? Well, the biggest problem we had by far was the work file formats, figuring out the difference between the ASCII and the SAG formats. And we didn't. We thought we understood it, and it seemed simple, but we ran into this problem over and over again where we would define it SAG or ASCII and have to go back and fix it. And that was, say, number one, hands down, biggest problem we had was work files, which is something you wouldn't think was the problem. But every time you changed it from ASCII to SAG, you had to go fix every place that used it. The sort statements were different depending on the type of file, because you had to tell the sort utility what type of file. Natural did it dynamically. It figured it out on the fly. You didn't need to change Natural in any way, but you did the sorts. And we had a few problems, because of having the formats, we had to have a conversion program convert the EBCDIC to ASCII, and it needed to know the exact formats. And we took a while to figure out exactly what files we needed and to get all the formats defined and which files were really the same formats. It just took a lot longer, and we had way more problems than we ever anticipated. The second problem, and really the 1 and 2 were the big problems in the system, the user acceptance testing. If we go back to the original schedule, it was defined for a certain number of weeks. I really just don't think that amount of time was enough. And the other trouble is we still had to do our normal jobs. So we just did not get the testing done as fast as we thought. again, my opinion, there wasn't enough time in the schedule. And secondly, I don't know how much time you could have put in. It just takes longer than you think to do the testing. And part of the trouble is we were learning. It takes time to learn how to use the new environment. So on top of learning new Adabas Natural, we had to learn a new everything else, and it just took time. So those were the two biggies. The rest of them I'm putting on here, but really 1 and 2 were the killers. Number 3 was the report distribution. Again, we had that concept of we did bursting, where we took the report and we'd break it up into little pieces. Well, we didn't really realize how much work it takes to define all of that bursting, and we didn't really schedule any time into the project to do that. And once we realized how long that was going to take, that was a big uh-oh, because that was weeks to months worth of work to set up all that bursting. And that wasn't in the project, and as soon as we realized that, we thought, uh-oh, this is going to be the one that comes along and kills us, that's just going to wreck the whole schedule. But luckily for us, Kronos came along and said, well, no, as long as you give us the old report distribution, an export of how they did it, we'll programmatically build all the report distribution set up for you. So they saved our butts by being able to do that. That wasn't something we planned, but thank you. Next problem was setting up the emulators on people's desktop. It was pretty easy to do for AVX people, but trying to get outside people to do it was a problem. I'll get a little more into it later. The RG conversions just took way longer than we expected because you had to really know what the program was doing to test it, and that's something that we could do that Kronos or SAG couldn't do. We had a few places where people had got real creative. Instead of just putting hex Fs or 999s at the end of a field to figure out the ending value, a couple of times programmers got pretty creative in how they figured out the ending values, and that didn't work, and those were hard to find. So we just kind of ran across those through the testing. Number 7 I'll put on here just so that you didn't think we forgot about it. There were simply some natural programming changes that just happened from version 3 to version 8. But it's at the bottom of the problem list because it really was very few problems. Adabas and Natural worked almost the same, and I wanted to mention it so you didn't think it was forgotten, but that was really small on the problem list. So let me go back, sorry for 1 second, talk about this. This is where I got in trouble, and this is where personally my big boo-boo when this project came along. We had the VT220 emulators, and we had to define them on AVX computers, and that was easy. We control those computers. There's MIS people in each of our plants around the world. We could send them, here's the software to install, go install it, here's how to set it up, and here's the date you need it, and it was done. We controlled those people. We're corporate headquarters. They got it all done. The trouble was our outside people. I crafted up these nice, beautiful emails to all these people and said, hey, we're going to have to change this stuff. Get ready for it. And then I crafted up more beautiful emails and said, here's exactly what you got to change. If you want to use our emulator or if you want to use your own, here's what you're going to have to change. Here's how to change it. Here's when we need it changed by. And if you have any problems, give me a call. Well, I got calls from lots of the people, and we went through and we fixed their emulators up, and then I sent out these nice big emails again saying, all right, we're getting ready to go. Do you have any problems, or is everybody okay? And if there's a problem, let me know. And 1 or 2 more people called, but basically we were in a good place. About a week and a half, 2 weeks before we go live, my boss comes along and says, are you really sure those reps and disties are all set up? And I'm like, oh, yeah. So she says, well, I'm going to call a couple just to confirm that everybody's good to go. Well, she calls them and we find out, well, I didn't really know what that email meant. So I just ignored it, or I didn't understand it. I just deleted it, or, oh, was I really supposed to do something? So about a week and a half or 2 weeks before we go live, we realized that about half of our external people couldn't get to the system. If when we go live. So that was a big ouch. 2 weeks before we go live, we're running around like crazy trying to get these outside people fixed. And if it was a small office where people controlled their own PCs, that wasn't too hard to do. But some of these distributors are big multinational companies, and they don't change the software on their PCs very easily. It's a lot of work for them, and they have their own change control procedures to make these changes. So it was a big struggle to get those people converted. So anyway, when we're ready to go live, we haven't met our August deadline, which was what we initially planned. And again, most of the problems were, again, the work files and the user acceptance testing. So we decided to go live at the August 22nd. Now, we had to go live right at the end of the month. Part of our contract with SAG was that they were going to put a person on site here to sit with us when we go live for a week. So we wanted to basically, we didn't want to go live at month end. That was just too risky to do. So we thought we would go live 1 week before month end. So we would process our weekend schedule, and they would be here, and we'd have some time to fix it if we had any problems before month end came along, and we'd still have the support people. So we were forced to go at the end of the month. So we're getting ready to go, and we phone up our plants and users and let them all know it's going to go live. So the plan is Friday we're going to run our old batch system, and we're going to run a whole bunch of reports because we've got auditors, and we've got to confirm that the data that loaded into the new system matches the data in the old system. So Friday night we kick the users out, we run the batch, and then we stop the scheduler when it's finished. And Saturday morning we send all the software off to Kronos to convert Adabas and all the work files, and they convert it all, and we load that into our new Linux world. And the first thing we do is we've got to run all of our same reports again because we've got to confirm that the numbers all match. So we make sure that it all matches, and the numbers are all good, and we get in and we run some of the online programs, some of the batch programs, make it looks good, and it's all fine. And then Saturday night, we'll run all on the new system, and we'll make sure the numbers look good, and if it's good, Sunday morning we'll let the users in. Well, Murphy came along, and Friday morning, the person who actually developed the whole scheduler routine, so a very critical resource, has a family emergency and has to leave. So Murphy's rule number one, something can go wrong, it will. We lose our critical person, one of our very critical people, right before we're going to go live. So if anybody's going to do a project, be prepared. So we go ahead with our plan, and we get a little bit bruised on the night. We had a couple of problems on Saturday night running batch. Nothing drastic. Basically on Sunday morning when we said users, we told them the system would be available, it was ready on that time. So we got through. It was kind of nervous that night, and we had a lot of people up all night long, but we got it in. Monday morning, everybody's got to get into the system using their brand new emulators. So we had put a couple extra people on our help desk. We sent out some books, manuals, kind of Q&A kind of questions for people, because a lot of people were going to get into the system. The hard part was getting into the system itself. Once you got into Adabas, it looked and worked the same. So that's where we got a little bruised. A little bloody was EntireX. We had write statements in our RPC programs. That blew up. One of the problems, and I'll get into this, rule number 2, install from an image. We installed on our test box one version, and I didn't realize that if you run the SAG installer, they can change the version on you. And that's what happened. So our test version worked. And when we got to production, it didn't work because they were different versions. So we got in trouble with EntireX. We had RPC commands that didn't work. Got that fixed. We ran into timeout issues on the mainframe. ACI servers don't time out. On Linux, they do. So that's where we got into problem. It took us about a week to get EntireX all up and working correct. So 1 month later, we're getting used to the system. First thing, it's really fast. Jobs are running 10 to 20 times faster than what they were before. CPU usage on our mainframe would go to 100% for 14 hours straight at month end. Now, just peaks and valleys, so much, much faster. We've had some emulator issues, just users don't like how the new emulator works. That's not a big deal. We tweaked the schedule a little bit, but after a month, we have never had to shut the system down because of a conversion-related issue. So it's up, it's working, and it is working fast. 4 months later, there's the IBM mainframe actually going out the door. We got rid of it. 6 months later, we're starting to use some of the new Software AG products, the entire access, the SQL Gateway, using Natural 1, which is the direction for all the new developers. We are fixing our DR, trying to make it so that we can recover much quicker, much shorter losses of data. And basically at 6 months, we would never want to go back. The new world is faster. Actually, it's got some things we don't like, but all in all, it's just a better environment to be in. So this is what we did. In a short time, we went from IBM mainframe running MVS to Linux, and from start to finish, 10 months was the complete project. So if we had to do it again, we'd test better. Good luck finding a project where you wouldn't say that. Number one issue was the work files, the SAG versus ASCII. If we had spent a little more time up front understanding them and how they work, I think it could have saved us. My 2 rules, Murphy, be prepared, and install from an image. That was my entire X problems where I put different versions on unknowingly. And the lesson I learned, if you send a big email to a user and say, tell me if you've got a problem and you don't hear something, that doesn't mean there isn't a problem. So if you don't get a response, that doesn't mean yes. That means I didn't understand it and deleted it. So that was my big boo-boo. And the number one thing we'd have done different if we could do it again was we'd have done it 5 years sooner. The system is so much faster. It's so many new features, new capabilities. We wish we would have done it way sooner. We love our new world. So we're coming up. We're going to start looking at app links, a little bit better integration with web methods. That's some of the new features that are come along with the new products. So I hope that answers most of what you're interested in. If you have any questions, please let me know.
Thanks, Randy. So let's, we're past the hour, so let me pose this to you quickly.
Sorry about that.
No worries. Very interesting stuff. Did you have to pull rules out of existing maps? Do you use Natural 1 or Construct?
We did not have to pull rules out of existing maps. We didn't really ever use map rules. We never liked them because it hid the code where you couldn't see it. So that's just not something that came up with us. There may have been some rules with maps, but as far as I'm aware, we never touched a map to change a map rule. We do not use Construct at all. We just code Natural. Looking down, one question is there cost savings in the Linux versions of Adabas and Natural versus the mainframe versions? We had dropped support, so we didn't have any costs when we were on the mainframe for Adabas Natural. So yes, we are now back under maintenance, so now we do have mainframe costs. To compare the cost of the SAG products, I don't have the costs of what it was on MVS and what it was on Linux. Where we had a huge cost savings, however, was in MVS. We didn't have to pay IBM for MVS anymore. The hardware that we run on is much cheaper.
Okay. Let me pose one last question to you. Were there any application security-related issues in making the platform transition?
Application security. Not really, no. We used Natural Security, and that was ported for us. And we used Adabas Security by Value. That also was converted for us. There was a couple of little glitches in the conversion, but no, there were really no security issues. The security issues were more a question of Linux security making sure that people couldn't get to the operating system, they couldn't get to files that they didn't need. So the security was more operating system security. It wasn't Adabas Natural application security.
Okay, and I'm going to fly against my rule. One last question. Was this rehosting only one system on the mainframe or every system on the mainframe?
It was every Adabas Natural system we had on the mainframe. We physically got the mainframe out of here. So it was a sales order entry system. It was a manufacturing system. It was a costing system. It was a customer forecast system. It was our entire systems. Rather than trying to convert one system at a time and having all these integration points that we need to convert, it was a pick up and drop, complete replacement all at once.
Okay. Randy, I want to thank you very much for your time, for the very detailed presentation today. We've had several requests for the recording. If you'd like the recording sooner rather than this evening, you can send an email to the webcast host. That email address is in the invitation you received. Otherwise, emails will go out later this evening that will have the YouTube link. So, Randy, again, thank you to you for your time and for the presentation. Thank you to everybody who has joined us today on this call. With that, our program has ended. Enjoy the rest of your day.